Hi, I'm Jade St. Peter, a master's student under Dr. Ira Mandel, and this is the effectiveness of adding legumes to grass pastures for stockpile grazing in Ontario beef systems, funded by Canada's Beef Science Cluster via the Beef Cattle Research Council. As many of you know, there's been an increased concern for greenhouse gas emissions with consumers, and some things we know about greenhouse gas emissions are that 63% of emissions from beef production is a product of enteric fermentation as a byproduct of digestion. 80% of beef production's greenhouse gas emissions is from the cow-calf industry, which means small improvements can make a large difference to overall greenhouse gas emissions. Our aim with extended grazing is to reduce emissions from breeding stock by utilizing pastures that sequester carbon for a longer period in the year. Cow-calf production relies strongly on conserved forages for winter months when pasture can't be grazed anymore. Greater environmental and cost inputs are associated with harvesting and transporting conserved forages versus pasture. Extending the grazing season and delaying confinement feeding can offset this. Pastures are a net sink for carbon, which can reduce greenhouse gas emissions from beef by sequestering carbon within the soil, which is a benefit you don't see from feeding cattle on a dry lot. Fields were seeded in 2019 with a mixture of grasses and alfalfa, grasses and bird's foot trefoil. The grasses in these mixes include orchard grass, meadow fescue, meadow brome, bluegrass, tall fescue, timothy, and fistolium. Our goal was to attain approximately 40% legumes within the fields seeded with legumes. Forage was mechanically harvested twice in 2020 in both June and mid-August, with rest in late summer to allow for accumulation of forage. These fields were sampled previous to harvest for dry matter yield and botanical composition. The start of grazing commenced after frost when forage reserves have moved into the roots to ensure survival of forages over winter for the next season. Sampling was weekly after the start of grazing, with quadrats for estimation of quality and dry matter yield and botanical composition to estimate forage species within the pasture. 48 pregnant Angus heifers weighing approximately 500 to 600 kilograms were put on 12 pasture fields with 4 heifers per field. 2.5 acres were in each pasture field with 4 repetitions of each of our 3 treatments as previously mentioned. Strip grazing was utilized and they moved based on the previous graze strip, being allotted more or less based on how well they grazed the previous strip, with no back fence used. We double weighed cattle coming on and off pasture and weighed and body condition scored biweekly once on pasture. Although not significantly different due to a short grazing period last fall, we did see changes in weight from start to end. Average daily gain ranged from 0.21 to 0.69 kilograms per day. Body condition score saw a slight decrease over the grazing period, again very small, and overall cattle gained weight. We see here alfalfa pastures had the best outcome for weight, body condition score, and days on pasture, likely due to a higher biomass and higher protein content of these pastures. Overall trends throughout the grazing period show an increase in dry matter as forage quality decreases in cold weather. There's a decrease in net energy of maintenance, net energy of gain, and total digestible nutrients as this happens, and a decrease in protein content. Forage starts to decrease in quality with below freezing temperatures, which we saw, and there was a decrease in digestible nutrients and an increase in fiber with cooler weather. Grass fields contained primarily orchard grass with some tall fescue, and the legumes present in the fields were primarily white clover with some trefoil. The legume fraction decreased as the season went on with wilting and leaf loss, and the grass fraction increased relative to legumes. To conclude, we had a shorter grazing period than expected due to low forage biomass. You really want to ensure an adequate rest period from July to mid-September. Lower biomass losses were seen with alfalfa and trefoil, which contradicts past data suggesting that cool season grasses were more stable below freezing temperatures. There was an overall greater biomass on legume pastures, and the average daily gain was better for legume pastures. The data suggests that stockpile pastures containing legumes increase forage biomass, pasture nutrient composition, and animal performance.